In this video, we're going to look at not condensing with log properties, but expanding with log properties. We're going to do what we did in the previous video, but in reverse. And so now if I'm looking at these, we have three examples right here where we're going to use these log properties to expand it. Instead of going from the right side of the equation to the left side, we're going to go from the left side to the right side. So let's look at this first example and try to look over here at your property, see which one of these matches this structure the best. And hopefully you're saying it's this one right here. I have log, a base, and then a product. I have a log, a base, and then a product. Well, that could be equal as log of the base of the first factor plus log of the base of the second factor. So our way that we would expand this is I would rewrite this as log base 6 of 7 plus log base 6 of 8. Let's move on to number 2. Let's first try to identify which of these properties looks most like the problem that we have, which one has the same structure, and hopefully you're saying this one, okay? So I have a log, a base of 8/7, that should be written as log, our base of 9, of 8, minus log, our base of 9 of 7. The numerator minus the denominator. Hopefully you see how we go from here to here. So let me just write it out. It's going to be equal to log base 9 of the numerator minus the log of the same base of the denominator. Let's move to our last example. The last example for this slide, I should say. The first thing I'm going to do before we go anywhere is I'm going to rewrite that radical as an exponent. Okay? So if I have log base 5 of the root of 8, that's the same thing as saying 8 to 1/2. And now that I've rewritten that radical as an exponent, you can see, oh, this is going to be this property right here, where I know that that exponent, that this exponent can be rewritten as a coefficient. So that's a pretty easy rewrite. I'm just going to rewrite as 1/2 log base 5 of 8. Okay? So all we're doing is we're practicing writing each of these logs in an equivalent form, doing a process we call expansion. We're expanding the log because we're making it bigger. Now let's look at this example. Don't be intimidated by all the variables. It's going to be the same deal as last time. So I really have two groups that are separated by this. So I'm going to do my first step with the division and rewrite as the log base b, in this case we have a base b, log base b of my numerator minus log base b of my denominator. So log base b of my numerator minus log base b of my denominator. Okay, and I did this in two different colors for a reason. Now I'm going to attack these like they're two little mini problems. Right here in red, I have a product. I have this situation, and I know that the factors of that product can be separated with addition. But here I have three of them, so I can do it through. I can do log base b of x plus log base b of y plus log base b of z. In fact, I'm going to do that real quick. Log base b of x plus log base b of y plus log base b of z. Okay? And I'm going to subtract whatever's over here. In fact, I'm going to do some stuff, so I'll probably need to put parentheses to show that I'm still subtracting whatever's there. But we have the same situation here. I have log base b of p squared times t to the 4th. So I can still use this property. Okay? So I'm going to do log base b of p squared plus log base b of t to the 4th. Notice how I use parentheses because I'm still going to be subtracting this entire quantity. I'm just rewriting this quantity, this highlighted quantity is this right here. And now everything in red to me looks good. I don't think that there's any way I can simplify that further, but I do see that I have some exponents here, so I'm going to use this property right here. Anytime I have an exponent, I can rewrite that exponent as a coefficient. So pardon me while I recopy everything. Okay, and so I'm just going to take that 2 exponent and that 4 exponent, I'm going to make them coefficients. So we have 2 times log base b of p plus, I'm going to run out of room, plus 4 log base b of t. And so we've taken this very condensed expression, we've expanded it out to here. Okay, let's look at one last example. In this example, we've got an entire expression in a radical. So just like, I think it was that, it might have been the third example in the first slide, I want to rewrite that radical as an exponent. So I'm just going to start by doing that. Log base b of all this stuff in the numerator, all this stuff. But if it's raised, or if it's square rooted, that's raised to the 1/2 power. And so before I do any of this stuff, I can apply this property first, okay? I want to rewrite that exponent as a coefficient out in front. So let me do that real quick. I have 1/2 log base b of x cubed y to the 5th over z to the m, okay? And so I have one group in the numerator, one group in the denominator, and so I'm going to rewrite that. Since I have the quotient, I'm going to rewrite it as subtraction. So I have 1/2 log base b of x cubed y to the 5th. I might throw parentheses so that this 1/2 applies to the whole thing. Minus log base b of z to the m. Okay? Hopefully you see why I included that parentheses, because if I didn't have the parentheses, only this part would have the 1/2 on it. Okay? Now, a little bit more expansion that we can do. I see that I have a product right here, so I can apply this property and rewrite that as addition. And let's do that first, and maybe I'll go multicolored here so we can see it. And then I'm going to rewrite the next part in blue. And I might just do this. I might squeeze this into this step right here since I'm running out of space. Our final step here is going to be to take each of these exponents and make them coefficients out in front. Okay? And so I'm just going to come up here to where I have space. And I'm just going to copy everything. So I have 1/2. It's going to become 3 log base b of x plus 5 log base b of y, and then minus m log base b of z. Now, depending on your teacher, they may want you to distribute that 1/2 into the whole thing. I don't really care. I am happy if you leave it right there.